Hello, students, and welcome to the lesson and discussion on problem solving with functions. And before we begin, one of the important things to remember about solving problems, and particularly word problems or story problems, is that it is really truly something very difficult. And there is no particular method or algorithm or clear list of steps that work every single time. Every single one of these problems is different. But there are a few principles that we can keep in mind that really will help you to solve these problems and become actually quite good at it. Okay? So one of the first ones is understanding the problem. And a lot of times students get things wrong not because they don't know the answer or because they don't know how to do the math. It's because they don't understand the problem. So ask yourself, look, is it even possible to solve a problem? Okay, what are the knowns and the unknowns? And particularly, I've underlined this part. What are the units of the answers? A lot of times, students solve a problem, and the units in the answer just really don't make any sense. Okay, and so if you can kind of keep in mind what it is that you're solving for, are you trying to get an equation as your answer, a pure number, a couple of numbers, and often students will get a partial solution, and not really finish the problem. Next is to devise a plan, and I've highlighted two of the things here. One is to draw a picture, and I'm sure your math teacher probably tells you to do this all the time, and it gets a little bit annoying. But the truth is that we teachers say this a lot because it really does work. It may not feel like it at first, but the better the picture you draw, it really does help you to visualize the problem. And if you can draw it many times, you can probably solve it. Okay, one of the other things I noted here is to use a variable and also write down the meaning of your variables, because a lot of times you might get a complicated equation with all these x's and y's and z's, and you kind of lose track of what these variables actually mean. Okay. And also to consider a few things like what are the methods that you can use to solve the problem. Is it graphing? Is it algebraic methods? Now sometimes it might be impossible to solve a problem algebraically. Other times it might be impossible to solve it graphically, and so you're kind of fixed on solving one way or the other. And if you know that ahead of time, it's also very helpful to you. But other times, either method works. It's just a matter of which one will get the job done faster and better for you. Okay. Finally, to carry out the plan, if it doesn't work, try something else. And these steps, they really cycle back on each other. Like if you carry out the plan and it doesn't work, you go back here and you try to study, devise a plan again. If you look back and it doesn't make sense, you go back and look at your plan. Okay, so it's not like you follow all this all the way through, but you kind of cycle back and forth a little bit. Okay? And just do it slowly. Work it out, one step at a time, showing all of your solutions. And finally, when you're done, look back at your solution to see if it makes sense. Like, did you actually answer the question? This is the biggest thing that students get caught up in, is that they get a partial solution. They make a ton of progress. They get an answer that's close to the real answer, but they haven't really finished it. Okay, and so these are, again, our principles that will help you to solve these types of problems. These problems are by design many times very tricky and challenging. The real world types of problems truly are tricky and challenging, and so you really have to work at this. It's a process. You have to be very patient, very persistent at solving these problems, and that's really the only way to improve, is to do a lot of them and to be persistent at it, and over time you get better and better at doing these problems. So let's see an example here. So I have a couple problems here. Let's look at the first one. It says one leg of a right triangle is twice as long as the other. Write the length of the hypotenuse as a function of the length of the shorter leg. And I've highlighted the phrase function of the length of the shorter leg because that's what we're asked to solve here. We should end up with a function as our answer, not as anything else. We're not looking for a particular number. Okay? So let me organize my notes here, and then we can sort of begin solving these problems. Okay, let me zoom out. So, since it says that it's a right triangle, I'm going to devise a plan. I'm going to draw a picture, because again, pictures are very, very helpful to us. So, and you don't want to go overkill and just draw like a million pictures. You want to think carefully about your picture, how it relates to the problem. So there's my triangle. Here's one of the sides. Here is the longer side. And I know that because it says one of the sides is twice as long as the other. And here is my hypotenuse. And I want to find a function using x for the hypotenuse. Okay? And since this is in fact the Pythagorean theorem, I mean a right triangle, I can use the Pythagorean theorem because it allows me to connect these variables together. So I can go, well, I have x squared plus 2x, and this is the important part that students often make a mistake on. It's 2x quantity squared. It's not just 2x squared, okay, which is equal to h squared. And then I can do the algebra here. X squared plus 4x squared is equal to h squared. These are like terms, so I can combine them together. 5x squared is equal to h squared. And I want this as a function of the length is a shorter leg for the hypotenuse. So I have to solve for the hypotenuse. I'm really close, so I can just take the square root of both sides. And that will give me square root of 5 times x is equal to h. And I can write, and since it's looking for a function, I can in fact write this as a function. I can write out, it's usually f of x, but I'll call it h of x is equal to square root of 5 times x. And there you have it, the final answer. And we can look back and think about this. Did we do everything? Did we answer the question? Well, the question is asking for a function, so we have a function. The length of the hypotenuse as a function of the shorter leg. So the shorter leg is the input, and the hypotenuse is the output. Okay. And there you have it. Now, there's a few other ways you can probably look at this and solve the problem, but I think this is the quickest, and I don't think there's too many other ways to go about this since we're kind of limited to the one particular right triangle here. All right, so let's try. This time it says that a square is inscribed inside of a circle. So let's draw that picture. That's a square inscribed inside of a circle. And it wants us to write the area of the square as a function of the radius of the circle. So I should get like, some function here, like area of the square is equal to something that's related to the radius of the circle. So I'll draw some of this thing in here. That's a radius there. This is also a radius out here. And maybe one of those will be useful to me. I'm not really sure yet. And I have to do a couple things here. One of the things I have to do is to sort of define the area here. And so I know that the area of a square is s squared, where s is the length of the sides of the square. Okay, s, these are s's, by the way, not 5s, okay? S's. Now I need to find the area of the square, not in terms of s, but in terms of r. So I need a way to, we need to connect r to s in some way, shape, or form. Okay, so I need to find some way to connect or write an equation, a relationship between s, and r. And if you notice, one of the things we can do is extend this here, and this is also r. And this object in here, this triangle here, is a right triangle. So we can again apply the Pythagorean theorem. And that will give us an equation using s and r. And that may or may not be helpful to us. So it's s squared plus s squared equals quantity 2r squared. And on the left side, we get 2s squared is equal to 4r squared on the other side. And I need to somehow, have everything expressed in terms of s. So I'm going to divide both sides by 2. And that gives me s squared equals 2r squared. But if we take a quick look, we're actually done with the problem because s squared is the area of the square. Okay, and that's really all we're asked to solve for. So we can now say that the area of the square is equal to 2r squared. Okay, because the area of the square is s squared is 2r squared. That means the area is also 2r squared. And the important thing to note is we're trying to find the area of the square using the radius of the circle. We start out by looking at the side lengths of the square, and then finding a connection between that and the radius, and then solving for s squared. And so this is actually our final answer. Okay, let's look back and see if we did everything we're supposed to do. Write the area of the square as a function of the radius of the circle. So I can also say, a of r is equal to 2r squared, if I really want to make that truly a function. Now let's look back again and see if there's another solution or another method here. Notice I kind of chopped this up into a big triangle, but it's also possible to do this, to make this a radius as well. And some people go that route, and there's absolutely nothing wrong with that. It turns out that this angle here is 90 degrees. To see that, you kind of have to remember a lot of things from geometry, but it's not too difficult to see. And I'm going to erase some of the other stuff here that's not entirely helpful to me. Okay, so if we just look at like this green triangle right here, we can also find the area of that. So the area of one triangle is 1/2 the base times the height. But in this case, the base is r, and the height is also r, which gives me 1/2 r squared. And the area of the square is just 4 times this. Okay, you have 4 triangles here, and so the area of the square is really 4 times the area of the triangle, which is 4 times 1/2 pi r squared, which is just 2r squared. And you can see here that this answer is the same thing as the answer that we got over here. We just did this problem in 2 different ways. One was using the big triangle and solving for s squared, which is the same thing as the area of the square. One is actually finding the area and then multiplying that by 4. And the interesting thing to note about the first solution is that we never actually found any area, which is kind of manipulated this thing using the Pythagorean Theorem. And by doing so, we have an equation or an expression that's the same thing as the area of the square. Okay, so I'm going to end this video here. We'll pick this up and do a few more examples in another video. But one thing that you should really note, and you should really just try to understand and internalize, is that this process of solving problems requires a great deal of patience and perseverance. Okay, and a lot of times if you're stuck on something, it's common and it's okay to be frustrated. Okay, but you got to keep working through it, because a lot of times if you're close to when you're frustrated is often when you're really close to getting the right answer. So keep working at it, ask for help, and try to keep a good and positive attitude about this, and that will take you a long way in mathematics, really in anything, but especially in mathematics. Okay, so keep working at it. Have a wonderful evening, and again, if you have a hard time with this, come see your teachers, and I'm sure one of them will be happy to help you.